Hello friends, welcome to Multiverse, and every day in the morning I meet you live on various social media platforms, and we are exploring the celestial bodies. We've already covered the solar system and we have moved out in the neighborhood, and right now we are exploring the celestial bodies which are close by. So today we are going to discuss about Struve. Struve is a close by red dwarf, and friends, as you know that nearly 70% of the stars which are found in our universe are the red dwarf stars, which are very, very small. So, what is this Struve system as some unique? Let's find out. Let's get into our imaginary spaceship and let's get into orbit of Struve system so that we can examine it up close. So here we are, and we are in the orbit of Struve. As you can see, the axis of Struve is directly looking towards Earth, so that is why it has this weird motion. But friends, this is a live feed, and we are examining it up close. So first thing is, this is a binary star system, and this is not a single star. There are two red dwarfs in this system, and they are present in the constellation of Draco. Well, when we talk about two binary star systems, the chances are there could be planets. So we will examine that in a bit, but these are very, very dim, very hard to look at because they do not produce too much light, and that is why you need an instrument or a telescope to really examine the Struve. Even though there are two stars, but again both stars are very dim and very hard to look at. In terms of distance, it is still very, very close by. It's about 11.6 light years away from us, and 11.6 light year is not too far from the universe standpoint, but it is pretty far from the human standpoint, simply because light itself takes 11.6 years to reach us. So that is why, even though it is very far off, but it is close by from the universe standpoint. In terms of the types of stars, these are the variable stars. When we say variable stars, well, red dwarfs are basically dim stars, and they produce a lot of red light. And when they produce a lot of red light, most of the red light is in the infrared spectrum. However, once in a while they flare up, producing more light than it's like 15 to 20 times that the star output is. So we really don't know why red dwarf flares up, but they flares up by giving out a lot of radiation and a lot of heat and energy for a few minutes, and the flare goes all around, unlike the solar storms on our sun, which are localized in one area because that is determined by the solar spot activities, dark spot activities. But in case of a red dwarf, which basically flares out in all directions, so it goes all over the place, and suddenly a dim object, you may think that this is something which is very, very peaceful, very calm, and very cool, but it will emerge into a big explosion of radiation and heat and light. So these are both of them are flare stars. They once in a while emit a lot of deadly radiation and a lot of heat and a lot of light. Well, scientists do not know why it happens, and there are certain red dwarfs which shows there is a set frequency, but many erupts without any frequency and without any external event or any external entity which is entering their solar system. They just flares up. So these two are also flare type stars. In terms of planet, there is nothing much interesting happening in Struve system. These are usual red dwarfs in the close vicinity, and they are a binary system, but there are three planets that we have seen so far. First of all, friends, I have to tell you that to look at a planet around a red dwarf system is very, very difficult, because is very, very hard to look at. It's difficult to even examine it. So once the James Webb laboratory comes to life, we will be able to see a lot of stuff in the infrared spectrum, and then we will be able to determine more about these stars that we have in the vicinity. However, so far we have found 3 large gas planets in Struve system. There are 2 planets going around one of the stars, and which is the smaller one, and one around the bigger star. Well, there are gaseous planet, which means that there could be possibility of setting up hydrogen harvesting mechanism. You know, when we have hydrogen fusion mastered in future, when we are able to master the fusion of hydrogen in future, we will be able to fuel that, use that as a fuel in our interstellar mission in future. And because of that, there could be these gas giants can set up, help us set up the fueling stations for our interstellar missions. So this is something which we can think of as a possibility, because there is nothing much interesting happening. And since this can form a good fueling station for hydrogen, which we can harvest from these gas giants on Struve system, there is a possibility of also managing a future space station. And there's lot of imagination happening to set up to support the interstellar flight and set up the space stations in Struve, so that humans can then stop over for some time for supplies and fuels, and then after that, after refueling, after relaxation, they can jump to a much further star system, which can be, so this can form as a midway, not for a long-term stay, but huge space station can be built which can support various flights in all directions, because these 3 large giant gas planets have a lot of hydrogen, and that hydrogen can be harvested especially for the long-term interstellar space missions. So this is something that we have to offer today in terms of uniqueness of Struve system. It is not so unique, it is like any other red dwarf, and nevertheless it is in the neighborhood of Earth and our Sun, and this is something that we know. I think we will get to know more facts about these red dwarfs in the vicinity once the James Webb open up its transponders and its instruments towards these stars, and we will start getting more features coming in from these star systems. So friends, hope you enjoyed the video today, and if you know more about Struve, do not hesitate to send in your comments, and I will respond to each and every comment of yours. For today, thank you so much for joining, and I will catch you again in the next edition of Multiverse.